How do you define a compressed liquid state? Imagine holding a sponge tightly in your hand. The more you squeeze, the denser and more compact it becomes. That's similar to what happens to a liquid when it is compressed in thermodynamics. A compressed liquid, also called a subcooled liquid, is a state where a substance stays in the liquid phase even though it is under higher pressure than usual. It is kept below its boiling point for that pressure, so it doesn't turn into vapor or steam. Think of water at room temperature and normal atmospheric pressure. It remains a liquid because it's below its boiling point at that pressure. But if you increase the pressure on water without raising its temperature, it stays as a liquid. This is because the pressure is higher than the saturation pressure at that temperature. Saturation pressure is the pressure at which a liquid begins to turn into vapor at a specific temperature. When a liquid is below this pressure, it can vaporize easily. When it's above, the liquid is in a compressed stage. On a thermodynamic diagram, such as a pressure-specific volume or temperature-specific volume chart, the compressed liquid appears to the left of the saturation curve, which is also called the vapor dome. This area shows liquids that are not about to boil or vaporize. The properties of these liquids, like their specific volume, enthalpy, and internal energy, are different from those of saturated liquids. They tend to have lower values because they are denser and more tightly packed. The properties of a compressed liquid depend more on temperature than on pressure. If you change the pressure slightly, it won't affect the properties as much as changing the temperature would. For example, water at room temperature and normal pressure is a typical compressed liquid. It's stable and not close to boiling. Engineers often use tables that list the thermodynamic properties of compressed liquids for calculations in systems like refrigeration, heating, or fluid transport. In summary, a compressed liquid is a liquid that exists at a temperature below its boiling point for a given pressure. It stays in the liquid phase because the pressure is higher than the saturation pressure at that temperature. This concept helps us understand how fluids behave under different conditions, especially in practical applications where liquids are kept under pressure to prevent vaporization.